Well, greetings, everybody. I have here two problems from the quiz. I think they're questions 20 and 22. If they're not 20 and 22, they're close to that on the quiz. And they both concern OR probabilities, and I'm doing this by request, okay? So for OR probabilities, we have two formulas that we'll use, okay? And this word OR, like when it says what's the probability of selecting a club or a six, that word OR should jump out at you, and you know we'd be using one of these formulas. Which one of these formulas we use depends on if the events in question can't both happen or can both happen. So we'll use this formula if the events we're given cannot both happen at the same time, and we'll use this formula here if they can both happen at the same time. So for example, take the odds of you take a card at random out of a deck, and you want to calculate the odds of selecting a club or a six. So just so that we're all talking about the same thing, here's what the deck looks like right here. There's clubs, diamonds, hearts, and spades. And each suit, clubs, diamonds, hearts, and spades, goes ace, 2, 3, all the way through king. Okay? So could both of these events happen? Like, could you draw a card and it's both a club and a six? Yeah, I mean, both of those events could happen at the same time. So we would be using this second formula. So if I do this first problem and say, what's the probability of a club or a six? Okay, I would do the probability of drawing a club at random from the deck. So like I'd say, what's the probability of getting a club plus the probability of getting a six, and then minus the probability of drawing a card that's both a club and a six. Okay, and then that would be it. So let's figure out what each of these is. What's the odds of drawing a club out of the deck at random? Well, so here are the clubs, and there are 13 clubs. 13, if you count these up, there's 13 of them. Okay, so there's 52 cards total, so that would mean the odds of getting a club is 13 out of 52. Okay, then I add what's the probability of getting a six. Well, it's going to be something over 52 because there's 52 cards. It's like, so I just have to figure out how many sixes there are in the deck. But there's a six in each suit. Like there's a six of clubs, six of diamonds, six of hearts, six of spades. So there's like 4 of them that I could pick out of 52 cards. So this turns out to be 4 out of 52. Okay, and then minus what are the odds I pick a card at random and it's both a club and a six. Okay, because we're using this formula right here because that's possible. It's possible you could pick a card out of the deck and it's both a club and a six. That's why we're using this bottom formula and not the top one. So let's think about it. How many ways can that happen? There's only one card in the entire deck that's both a club and a six, and it's this one, the six of clubs. So that would make the odds of that 1 out of 52. Okay, whoops, 1 out of 52. All right, so then if I do a little math, figure out what this number is, I'll get 16 out of 52. Okay, and then it says to round to 3 decimal places, so I'll figure out what that is with my calculator. 16 out of 52, so that turns out to be 0.3076. 0.3076. Now, if I round that to 3 decimal places as requested, I'll get 0.308. Okay, so that's why this answer, the correct answer that you see there, is 0.308. Now, I won't do the second one because the second one is like this: a red suit or a jack. Those can both happen. You could draw a card that's both a red suit and a jack. Think about the deck. These are the red suits. And then there's two jacks that are diamonds and hearts. So you would work that one the way that I worked this first part right here. Okay, both of these events they can both happen, a red suit and a jack. Now, but let's look at the last one for a little variety. What's the probability of selecting an 8 or a face card? Now, can these events both happen? Like, could you pick a card out of the deck and it's both an 8 and a face card? Because which formula we use depends on if the events in question can't both happen at the same time or can both happen at the same time. This is not, you can't pick a card out of the deck and it's both an 8 and a face card. So we would use this first formula up here. Okay, so let's see, I'll do probability of drawing an 8, whoops, probability of drawing an 8 or a face card. And by face card they mean jack, queen, king. Okay, and like you can't pick a card out of the deck that's both a face card, which is one of these, jack, queen, king, any suit, and an 8. Like those are just different things. There's no overlap between them. There's no way you can pick both. Okay, so I use this first formula right here. It's just going to be the probability of getting an 8 at random plus the probability of getting a face card at random. Okay, so what are the odds of drawing an 8? Alright, so I have, well, 8s. There's 4 8s in the whole deck, one of each suit, out of 52 cards total. So that's going to be 4 out of 52. Okay, and then for probability of face cards, again, that's going to be something out of 52. I just have to figure out how many face cards there are. Okay, what are the odds of drawing a face card? Well, there are 3, 6, 9, 12 face cards total. So I get 12 out of 52. Okay, so 4 out of 52, 12 out of 52. If I add that together, I get 16 out of 52. And if I use my calculator again, I'll get 0.3076. Okay, that's why that answer rounded to 3 decimal places is 0.308. It's just a coincidence that the answer to part A and C are the same. But you see the difference. I got my formulas. I have to decide, those events they give me, can they both happen? Okay, if so, I use the second formula. Or if they can't both happen, I use that first one. All right. Okay, so let's look at this other problem, which also deals with OR probabilities. The way this is given to me is that there's a group of people, some males, some females. Some of them support something, some of them oppose something, and some of them aren't sure how they feel. Okay, so we can look at this the same way because it's again asking for an OR probability. It says, what are the odds that, say you got this whole group and you pick somebody out of the group at random and they oppose the tax, okay, so they oppose, or they're female. Okay, well, can both of those events happen? Could you pick somebody at random that opposed the tax and was also female? I'd say yeah, because there's 308 females that oppose it. So I would have to use this second formula because those events that are given can both happen at the same time. I can pick somebody at random and they could oppose the tax and they could be female. It's possible. All right, so we'll work like this. We'll say, all right, I'm gonna get that answer this way. Probability oppose the tax or female. Okay, I'm going to use that formula that I point out up there. That'd be the probability that they oppose, meaning what's the probability that I pick somebody randomly out of this group and they oppose the tax, okay, plus the probability that a random person chosen out of that group is female, minus the probability that they oppose the tax and at the same time are female. Okay, so that's how I do it. So let's think about this one. What are the odds that I pick somebody at random out of this group and they oppose the tax? Okay, well, I'd have to think, how many people oppose the tax versus how many people are there total. Okay, well, among the people that oppose the tax, there's 331 males, 308 females, 639 people total. So there's 639 people total who oppose the tax. But how many people are there altogether? Well, I'd have to add up those that support, those that oppose, and those that don't know how they feel. That's 1070. So 1070. Okay. So that's the odds of picking somebody totally at random out of this group and that they oppose the tax. Just count up the number that oppose and divide it by the total number of people. That's how you do it. Okay, then plus, what are the odds I pick somebody at random and they're female? Well, okay, so there's a certain number of females that support this, there's a certain number that oppose, there's a certain number that are unsure, but the total number of females is 573. Okay, so there's 573 females in this entire group of 1070. So that's the odds of picking somebody at random from this group that's female, 573 over 1070. Okay, so I've got the odds of picking somebody at random that opposes, the odds of picking somebody at random that is female, and now I got to subtract what are the odds I pick somebody at random out of this group that opposes and is female. Well, it's going to be something over 1070. It's going to be however many people in this group both oppose this tax and are female, divided by 1070. So that would just be this number, right? This number, 308, is the number of females that oppose the tax. Okay, these people right here, 308 of them, are both in opposition and are female. So I do 308. All right, so that'll do it. That'll get me this number right here. I figure out what it is for you. So I got 639 plus 573 minus 308. So I get out of that 904 out of 1070, and I'll divide that and get you the decimal, and that's going to be 0.8448. So 0.8448. So that's why you see this number right here, 0.845. That's that number I got from my calculator rounded to 3 decimal places. Okay, so we can approach it the same way. We just got to figure out, can the events in question both happen at the same time or not? And then we have our formula, and then that will involve from there calculating these individual probabilities. I'll make quick mention of these other two. Find the probability that the person supports the tax or is male. Okay, that'd be like this first one, because these could both happen. There are people that support the tax and are male. Okay, so you'd use this formula in the same way, but it'd be supports or male. Probability of supports or male. Okay, and then what about this last one? Probability that somebody selected at random is not unsure. Okay, so not unsure would be either support or oppose or is female. So that's like, we're talking about all these people, 393 of them plus 639, those are not unsure because they know they support or oppose, or is female. Well, those can both happen. You can pick somebody out of this group at random that is not unsure, that'd be over here, and is female at the same time. Okay, so for all 3 parts of this, we would use this formula right here. Okay, because every single pair of events that's given in question in each of these could both happen. All right, so that's how we make our decision and our calculation on OR probabilities. This from the quiz, so I didn't do all parts of these. Let me know if this is enough to get your thinking in the right direction for this type of question. Otherwise, I can make another video that's more detailed and addresses the other parts specifically.